Right, question 3 of the 2013 paper is the Chinese postman. And if we have a look here, Jeff is planning a car tour. He needs to drive along all of the roads in the diagram at least once. That's a typical Chinese postman problem. And he wants to keep his total distance to a minimum. First task for a Chinese postman is to identify your odd vertices. Okay, so for us here, these are the odd vertices. I've put little stars on them. They've all got an odd number of edges coming from them. 3 from H, 1 from S, 3 from C, 3 from K. Okay, so usually get a mark for writing down your odd vertices. So there they are, C, S, H and K. And then what we need to do is we need to split those 4 into pairs. So 2 vertices plus another 2. And there are 3 ways of doing this when you've got 4 odd vertices. So there I've written them down. I've paired CS and HK, CH and SK, CK and HS. Having got the pairings, we then need to work out the shortest distance between them. We need to be rather careful here. So between C and S, for example, the shortest route is actually going straight via I. 7 plus 12 is 19. Doing the shortest route from H to K, there's H and there's K. Is it the 21? No, it's not. You've got to go via G. 7 plus 12 gives us 19. So adding those two gives us 38 for our shortest distance. Now, the next pairing, CH and SK, if we just check those distances, CH, the shortest distance, actually turns out to be 23. If you try the different sort of ways you can get from C to H, 19 plus 7 gives us 26. Okay, but that's not the shortest way, because if we went via D and G, 8 plus 8 is 16, plus 7 is 23. Okay, and the next one along, SK, if we have a look at that, now this is going to be a little bit more difficult because they're totally opposite sides of the diagram, but you can see that out of the different ways to get from K down to I, the shortest one, if you check them all, turns out to be 14 plus 5, so that's 19, plus another 11, so that's 20, 30, plus 12, 42. When you add those together, you get 65. Last pairing, CK. If we check where that 24 came from, it's via B. That's the shortest way of getting from C to K. And then from H to S, the shortest distance there turns out to be 19 plus 12. That's 31. So adding those, 55. Once you've worked out your 3 distances that connect together the paired vertices, then you identify the shortest of those. And for part A of the question, find the length of an optimal Chinese postman route. They always give you the total length for the whole network. Okay, so you don't need to work that out yourself. So you just add your 38, the shortest of the 3 pairings, to the distance that they gave you at the top, and you've got your 181 miles for the Chinese postman route. Now, then we start getting on to more complicated questions that are related to this. So this time we're given a start and finish time. Jeff starts at C and finishes at 8. Find the length of an optimal Chinese postman route. So always what you do is, when you're given a start and finish, the value that you add to the total for the network is always the one next to it. So if CH has got a distance of 23 between it, you're not adding the 23, but you're adding the one next to it, because it's the bit of route between S and K, the other odd vertices, that you actually need to repeat. So you need to add your 42 this time onto the 143, and that gives you 185 miles. So it's not the start and finish vertices that you repeat, it's the one next to it, 42. Now the last bit of the question asks you, given that Jeff can instead start at any place and finish at any place, find the length of an optimal route. So if you can choose where to start and finish, then obviously the bit of route that you're going to repeat is going to be the smallest one out of the 6 values that you've worked out here. And of course we've got 2 smallest that happen to be the same, so that's fine, 19. So we add the 19 onto the total 143 that they gave us. That tells us that this route is now 162 miles. Okay, and of course, whichever bit of route you repeat, it's the one next to it that you start and finish at. Now, of course, ours turn out to be the same, which means we've got two options here. So we could start and finish at C&S, or we could start and finish at H and K. So I've just put here, start and finish could be C stroke S or H stroke K. Okay, it can't actually be a different combination, so you couldn't combine C and H or S and K. Okay, it's got to be the two pairings that we had here.